Hey, this is Mr. Aiden, and this is Chemistry 1 Honors video for pH calculations. You're going to need a calculator, and we're going to take a look at some pH calculations, which when we take a look at them, they will first seem to look really difficult, but as we go along, you'll find out they're really easy. So follow me as we go along. So all of our pH calculations are these calculations. We have one of them, which is pH plus pOH equals 14. So if something is neutral at a pH of 7, its pOH is also at 7. And so it always adds up to 14. We know that below 7 we have acids and above 7 we have bases. Now from that equation we also know that the H plus concentration times your OH minus concentration equals 1 times 10 to the negative 14, or 0.0000, 13 zeros with a 1 after them, which means this is actually in a logarithmic scale, and you'll find out this is a lot easier than it even looks. We can find the calculation of the pH by taking a look at the pH is equal to the negative log of your H plus concentration, which the algebra behind that means your H plus concentration is 10 to the negative of your pH. Now keep in mind, we can only use that pH calculation if we have a strong acid, because we know that dissociates 100% into H plus, but we can find the H plus concentration from any amount of pH. I'll make that clear as we go to our practice problems. We also know our pOH is equal to negative log of OH minus, which means the algebra behind that is the OH minus equals 10 to the negative of your pOH. So let's get through some problems, and I can show you these pH calculation equations in real world situations. So let's take a look first at calculating pH from strong acids. And so we have our first one. We have a 1 times 10 to the negative 4 molar solution of HCl. So we want to find the pH. pH equals negative log of my concentration. What's my concentration? Is 1 times 10 to the negative 4, which means if I put that in my calculator, just put it in your calculator, negative log is just a button on your calculator, 1e negative 4, and you would get a pH of 4.00, which means this number right up here is going to be very close. If not, if you have 1 times 10 to the negative 4, it's going to be exactly a pH of 4. And we had a strong acid, we had HCl, so we could use our pH equation. The next one, we have 2 liters of a 2.5 molar times 10 to 2.5 times 10 to negative 3 molar solution of HNO3. What do we know about HNO3? It's a strong acid, so I can use my pH calculations immediately because it dissociates 100%. Negative log of my concentration. What's my concentration? It's 2.5 times 10 to negative 3. It doesn't matter how much I have of that. We can do my pH calculation. Put it in your calculator. Try this one. Negative log of 2.5 times 10 to negative 3, or 2.5 e negative 3, and we end up getting a pH of 2.60, which tells us we have an acid. Also, take a look. See that negative 3 right there? We know that it's going to be very close to that number right there, so that is our pH. Let's go to the third example. We have a 0.0100 molar solution of HF. What do we know about HF? HF is a weak acid. What do we know about weak acids? This is not the concentration of your H+. There's only a small percentage of H+ in there, which means we cannot do our pH calculations because it is not a strong acid. So let's go to calculating your H plus from your pH. Now this doesn't matter whether it's a strong acid or weak acid because the pH is the amount of H plus. It's the measurement of the amount of H plus in your solution. So here we want to know the H plus from a solution of HCl with a pH of 3. So to find your H plus concentration, we're going to do that algebra, 10 to that negative of our pH, 3.00, and we end up getting 0.00100 molar of HCl, or you could say 1 times 10 to the negative 3rd molar of HCl. We have a pH of a weak acid is 2.50. Remember, I said that you can't find the pH of a weak acid using your pH calculations, but you can if you know the pH is 2.50, then that gives us how much H plus concentration we have, which means we do 10 to the negative of 2.50. You do that in your calculator and you end up getting 0.00316 molar of my weak acid. Okay, so that's calculating the H plus from your pH. You can do that with weak acids, strong acids, doesn't matter. Now let's take a look at calculating our pH from a strong base. Okay, so we have strong bases. Here I have NaOH. Sodium hydroxide is a strong base, which means, remember, it doesn't have an H plus in it. It has OH. So I can find my POH, which means I do negative log of my OH minus. It dissociates 100%. So I'm going to do negative log of 1 times 10 to the negative 5. I do that in my calculator, I get 5.00. But that's my POH because it dissociated into sodium ions and hydroxide ions, which means to find my pH, I'm going to take 14 minus my POH, or 14 minus my 5, and I get a pH of 9.00, which tells me I have a base, in this case, a strong base. Here, the next problem, I have a POH of 4.50 of a strong base. I already have the POH. What do I know about the pH? The pH equals 14 minus the POH, because pH and POH equals 14, which means I do 14 minus 4.50, and I end up getting a pH of 9.50, which tells me I have a strong base. Okay. So hopefully this helped. This was our pH calculations video. I know it was quick. Go to MrAiden.com, do the self-assessment to figure out whether you're good on pH calculations. Get out that calculator, do that self-assessment, and I'll catch you on the flip side.